There are two reactions of electrophilic aromatic substitution that I asked you guys to write it from NCERT. I also told you guys that carboxylic acid is a meta-directing group. It is going to give you meta products. Okay. So I hope you have written both of those reactions. And then please write in amines, the first topic is method of preparation of amines. Right here. The first method of preparation of amine is by reduction of nitro compounds. Reduction of nitro compounds. Now, reduction of nitro compounds can be done in two different ways. First of all, it can be done either by hydrogenation in the presence of a catalyst. A catalyst can be nickel PD or PT. Okay. So first, please write number one. If you have RNO2, H2 in the presence of palladium, platinum, or nickel, you are going to get RNH2 with the same number of carbon atoms. So for example, if you have NO2, H2PD, you will get NH2. Similarly, it can also be used to reduce nitrobenzene to get aniline. This is aniline. Another way of reducing nitro is by using any metal such as tin and iron in the presence of HCl. So if you have RNO2, iron or tin in the presence of HCl, you will get RNH2. This can also be used to reduce nitrobenzene. To get aniline. Once you're done with this, please write a note. Please write reduction of nitro compounds for formation of amines is wait a second. एक second रुक जाइए. Let me write it once again. Please write here. When you use Fe in the presence of HCl, Fe plus HCl is preferred for the reduction of nitro compounds to amines, as FeCl2 formed is easily hydrolyzed to release HCl. and this HCl can be reused in the reaction. That is why a very small amount of HCl is required. Okay, so when we have Fe plus HCl, we will get FeCl2 as a byproduct. Okay, and this byproduct FeCl2, if you react this with H2O, this is going to again give you HCl. And when you get HCl, this HCl can be again used in the reaction. So we are going to get HCl, which is going to be used in the reaction once again, right? Therefore, a very small amount of HCl is required. Second method of preparation, ammonolysis of alkyl halides. In ammonolysis of alkyl halide, we have seen this reaction in haloalkane and haloarenes. So when you have ammonia and RX, a haloalkane, this is going to have delta positive because it is connected to electronegative element halogen. The nitrogen is going to have a lone pair electron, and it can attack the R group here. It will attack the R group here, and it is going to form NH3 bonded to R with a positive charge and X negative. Okay, so this is substituted ammonium salt. Substituted ammonium salt. A further reaction of substituted ammonium salt with NaOH in basic condition, we are going to get RNH2. We are going to get RNH2. But the reaction will not stop here. If your alkyl halide is in excess, then this RNH2 can again react with the alkyl halide, because this nitrogen still has a lone pair electron. It will again attack this R group and it will replace the hydrogen atom. So you will have R, N, H, and one more R here. Okay, now still this nitrogen atom, it is having a lone pair electron. So it is going to again react with alkyl halide, leading to formation of tri-substituted amine, R, and one more R. Now still it is having a lone pair electron, so it can still react. And it is going to give you quaternary ammonium salt, which is having 4 alkyl groups attached to nitrogen and with a positive charge on nitrogen. Now it does not have any lone pair electron, that is why it cannot react further. So this is quaternary ammonium salt. So this is your 1 degree amine. 1 degree amine, this is 2 degree amine. This is 3 degree amine. Okay, so all types of amines are formed here whenever you are having ammonolysis of alkyl halide. And therefore, ammonolysis is not a very preferred method of preparation for amines. Why? Because it can give you 1 degree, 2 degree, 3 degree amine. All of them are what? All of them are in a mixture. So please write, note, ammonolysis is not a preferred method not a preferred method of preparation of amines, as it gives mixture of 1 degree, 2 degree, and 3 degree amines. 1 degree, 2 degree, 3 degree, and quaternary. Na? 1 second. 3 degree and quaternary amines. Now, in order to get primary amine, what we can do, we can have the alkyl halide in a very small amount, and we can have excess of ammonia. If ammonia will be in excess, then only alkyl halide can react with ammonia only. Okay, so because all of the alkyl halide can react instantaneously with ammonia, there will be no alkyl halide remain to react with 1 degree amine. Please write next. To get amine as a major product, rather to get 1 degree amine as a major product, NH3 should be in excess. Now, if I talk about the reactivity of different alkyl halides, please write order of reactivity of haloalkane. Then the haloalkane which is having the most easy leaving group, the good leaving group, the best leaving group, that is going to be most reactive. How easily can you remove the halogen atom? In terms of that, we have iodine, which is the good leaving group. Ri will be the fastest, followed by RBr, followed by RCl. RF is not also in the concentration. Please write this down. Done, everyone? Yes or no? Please tell me.
Yes, sir, done.
Right, next. Reduction of nitriles. This is the third method of preparation. Reduction of nitriles. Now you can use 3 different reducing agents for this. Please write the 3 different reducing agents. You can have lithium aluminium hydride, LiAlH4. Secondly, you can use hydrogenation in the presence of nickel or platinum or palladium. Third, you can use sodium amalgam, NaHG, in the presence of ethanol. These are the 3 reducing agents that you can use to convert. These are the 3 reducing agents that you can use to convert what? To convert nitriles into amines. You will have R, C triple bond N, H2 in the presence of nickel. You will be getting R, C, H2, and H2. So this carbon atom gets 2 hydrogen. This nitrogen also gets 2 hydrogen. Okay, simple. So if you have a benzonitride, in this case, you will be getting CH2 NH2. This is not aniline. ठीक है ना, इसको please याद रखिए. This is benzyl amine. This reaction is important if you are having if this reaction is important for the conversions question. Okay, we will do one question. Please write this down. They're asking how will you convert ethanol to let us suppose propane nitride. Okay, so ethanol, it is having 2 carbon atoms and OH. 2, 1, 2, 3 carbon atoms. 1, 2, 3 carbon atoms, and then here you have NH2. So for this, we will start with SOCl2, converting this OH to chlorine. After that, we will do the reaction with KCN. This KCN is going to add CN here. And after this, you can use LiAlH4 on any of the reducing agent. So this carbon atom will get 2 hydrogen. This is the carbon atom here, and this nitrogen is getting the 2 hydrogens. Please write this down. So here you had 2 carbon atoms. Here you are having, this is 2 carbon. Here you are having 3 carbon. It's important for these type of conversions. Right, next. The fourth method of preparation. Reduction of amides. General formula of amide is RCONH2. This can be reduced by lithium aluminium hydride. The second step, we add water, and we get the number of carbon atom is going to be same. Here you have R and C. You have R and you will have C. This carbon atom will get 2H2, and this NH2 will be as it is. Okay, so from removal of oxygen, addition of hydrogens, reduction of amides. Done, everyone? Everyone done? Yes or no, please tell me.
Done, sir.
Okay. Next reaction is important. Gabriel phthalimide synthesis. Fifth method of preparation. Gabriel phthalimide synthesis. You remember phthalimide from the previous chapter, है ना? Phthalimide in carboxylic acid, जब आपके पास 2 COOH group होते हैं benzene ring में in ortho position, right? If you remember that reaction, see here we have, first of all, we start with phthalimide here. NH, C double bond O, C double bond O. Okay. Now, this hydrogen atom that is attached to this nitrogen atom, it is kind of acidic. Why it is acidic? Because if you remove this hydrogen, what you will get? You will get a negative charge of nitrogen. This nitrogen can have resonance with this oxygen also and this oxygen also. So it is resonance stabilized. That is why it is slightly acidic. So if you react this with KOH, so this hydrogen is acidic, and you are going to get nitrogen, double bond O as it is. Because you removed hydrogen, you will get a negative charge, and this K positive will be there as a salt to stabilize this negative charge. Okay. Now, once you have got this negative charge, I can add Rx. Rx will be what? Rx will be any alkyl halide, any alkyl halide. Now this R is having delta positive, nitrogen is having delta negative, so it will attack on the R, and K will be replaced by R. So we'll have the same thing. Nitrogen, which is attached with R group here. See, this is double bond O, this is also double bond O. No change till here. इसको क्या बोलते हैं? This is known as, ये जो थैलेमाइड है आपका, this is thaliamide. This is your N-alkyl thalamide. N-alkyl thalamide. This is, if it is methyl, it will be what? N-methyl thalamide. If it is ethyl, it will be N-ethyl thalamide. Now, once you react this with NaOH in aqueous, NaOH, it gives C double bond O, O negative, C double bond O, O negative, and both of these negative charges are stabilized by Na positive. Plus, we get this RNH2. This R is coming from the alkyl halide. This R is coming from the alkyl halide. This is will be 1 degree amine. Okay, so it is a long but good method of preparation of 1 degree amine. Please write this down. This reaction जो यहाँ पे हो रहा है ना, this is SN. It attacks here. This reaction is SN. SN important है यहाँ पे. Why? Because we cannot get, if we are using any aryl halide, है ना? For example, we are using chlorobenzene. तो chlorobenzene वगैरह nucleophilic substitution reaction नहीं दिखाते. So we cannot prepare aniline or aromatic amines from this method. ठीक है? So this attack from nitrogen to R is what? It is SN. ये ध्यान रखिएगा. You write here first point. Used for preparation of one degree amine. Used for preparation of 1 degree amine. That is primary amine. What happens here? Thalamide on treatment with potassium hydroxide forms potassium salt of thalamide. Then what we are doing? Then we are treating it again with alkyl halide, and there is some heat required here in order to break this bond. This N minus and K plus. Then right here, potassium salt of thalamide which on treatment with alkyl halide which on treatment with alkyl halide forms an alkyl thalamide. Right, on further alkaline hydrolysis, on further alkaline hydrolysis, it forms primary amines. राइट अ नोट। हम लोग क्या नहीं बना सकते इससे, वी कैन नॉट गेट aromatic primary amines. Okay, please write aromatic primary amines cannot be prepared by this method as they don't undergo SN. Then everyone, yes or no, please tell me. All of you done writing?
Done, sir.
Right, next, the last method of preparation. Hoffman bromamide degradation. So, Hoffman bromamide degradation. Okay. In Hoffman bromide degradation, we get primary amines, but we get the amine, it will be having one carbon less than the amide. If amide has RCONH2, the reagents are bromine plus some alkali such as KOH or NaOH, and we are going to get RNH2. Okay, what we are going to get? This CO you will remove and you will get RNH2. Plus you can get K2CO3 plus KBr plus H2. These are not very important. This is important. Okay, so please write. Used to prepare 1 degree amine. 1 degree amine from amide. Reagent क्या है यहाँ पे? Reagent is Br2 plus KOH or NaOH. The amine formed has 1 carbon less than the amide. So for example, if you have a benzene ring and CONH2, Br2 plus KOH, you will get aniline. Please write this down. Done everyone? Yes or no? Please tell me. All of you wrote this down?
Yes, sir.
Right, next. The physical properties. Now, in physical properties, we'll first of all write about the boiling point. Please write. Amines can form hydrogen bond except tertiary amine. ठीक है, except tertiary amine, because tertiary amine के पास हाइड्रोजन ही नहीं होता है. Okay, so हाइड्रोजन है नहीं तो हाइड्रोजन बॉन्ड बनाएंगे कहाँ से? Okay, hydrogen should be connected to any electronegative element. Here electronegative element is nitrogen. So if you have tertiary amine तो यहाँ पे नहीं है. If you have primary amine, so it is obviously it is having nitrogen and two hydrogens. So these two hydrogens can form hydrogen bond. Amines can form hydrogen bond except tertiary amine. Hence, they have higher boiling point than corresponding hydrocarbons and polar molecules. ठीक है, please write next. But boiling point of amines is less than that of alcohol and carboxylic acid. Why? Because hydrogen bond in alcohol and carboxylic acid is formed by more electronegative oxygen atom. Hence, the hydrogen bond is stronger in alcohol and carboxylic acid. Done everyone? Yes or no? Please tell me. यहाँ तक लिख लिया आप लोगों ने?
Yes, sir.
Now, right next. अब देखिए, if I talk about amines itself, यानी primary amine, secondary amine और tertiary amine में, so if I compare the amines, in that primary is going to have more number of hydrogen bond. Okay, so please write. Since 1 degree amine has 2 hydrogens, for the formation of hydrogen bond, it has the highest boiling point, followed by 2 degree and 3 degree. Okay. If I just compare the different types of amines, primary as the highest, followed by secondary, followed by tertiary amine. Now, regarding solubility, please write. Amines are soluble in water as they can form hydrogen bond with water. But the solubility decreases rapidly on increase of carbon atom in alkyl chain. Okay, also write next. Amines are less soluble in water than alcohol due to lower electronegativity of nitrogen atom. Done everyone, yes or no, please tell me.
Yes, sir.
Okay. Right, next. Chemical properties. Okay. In chemical properties, there is a topic of basicity of amines. Okay. But we will look at basicity at the end. We'll start with simple reactions here. So write the first reaction of amines, that is alkylation. Alkylation reaction we have just seen. Alkylation में क्या होता है? If you have RNH2, this is amine, okay, and you react this with some R dash X, that is a alkyl halide, we are going to get R NH2 R dash with a positive charge on nitrogen atom. And if you further react this with any base, you are going to get R NH R dash. Okay, so we have seen this reaction just now. अब इसके बाद this can have further reaction R dash X के साथ. So this is known as alkylation. Alkylation का मतलब क्या हो रहा है? This nitrogen atom is getting a alkyl group here. Okay, this nitrogen atom is getting alkyl group here. Okay, please write. Primary and secondary amines. Reacts with alkyl halide to form tertiary amines. Okay, so for example, you have CH3 NH2. You react this with 1 carbon, 2 carbon, and Cl. You have chloroethane. So what you are going to get CH3 NH. अब हम ऐसे लिखेंगे तो I hope all of you are understanding this. That this is 1 carbon atom, 2 carbon atom. Then further reaction will happen with chloroethane. We will get CH3 nitrogen, 2 carbon atoms like this, 2 carbon atoms like this. Okay, so in this case, what we are having these carbon atoms. Just a second. This and this groups are coming from the alkyl halide. Okay, the haloalkane. So this is the alkylation. We are adding an alkyl group on the nitrogen atom. अच्छा, इसका नाम कौन लिख पाएगा ये बताइए तो जरा. Can anyone tell me how to write the name for this compound? हाँ guys, how to write the name for this compound? Anyone has any idea? Please raise your hand. The rules are same है ना, जो हम लोगों ने पढ़ा था, स्पफ वाला ही है. Identify the functional group, unsaturation, parent carbon chain, and then you can identify the substituent. जो खेल है main, that is on the numbering. Okay, चलिए ठीक है. Let us see. What is the functional group here? Since there is nitrogen atom that is attached with alkyl group, so my functional group is going to be amine. Functional group is amine. Unsaturation, since we don't have any double bond or triple bond, unsaturation is going to be AN. Now, what will be the parent? Now, for parent, I have 3 different groups that we can look at. Okay, either this is my parent, or I can say this is my parent, or I have this as a choice. Either this is my parent. Now, obviously, I'm going to choose the carbon atom that is having the most numbers, right? Because all of them are connected with nitrogen only. So they are directly connected to the functional group. So that is not a matter. We have to choose the one which is having the longest chain. So we can either choose the first two. So I'm going to take this as the functional group here. Okay. So this is my, sorry, I'm going to take this as my parent carbon chain. Now, parent carbon chain has how many carbon atoms? 1 and 2 carbon atoms. So this will be what? Eth. Now, what are the substituent? After the identification of puff, whatever remains is the substituent. So whatever remains is a methyl group and an ethyl group. So please see, my substituents are methyl and ethyl. Now, how to number this? Where is the ethyl group attached? Where is the methyl group attached? Now, obviously, we can see that the methyl and ethyl group, these are not attached directly on the carbon chain. It is attached to nitrogen. So for both of them, I am going to give the N-methyl, N-ethyl. So what will be the name here? It will be N-ethyl with alphabetical order, N-ethyl, N-methyl, ethane 1 amine. Got it, guys? Yes or no? Please tell me. सबको बात आ गई समझ में? How to write the name for these type of compounds? अरे हाँ या ना?
Yes, sir.
Okay. Similarly, name of this compound is going to be N-methyl, because we have only methyl group, N-methyl ethanamine. Please write this down. जी लिख लिया आप लोगों ने? Done everyone?
Done, sir.
Right, next, acylation. ठीक है. In acylation, this acylation, it can happen with primary amine, secondary amine, or any aromatic primary amine. ठीक है. So please remember, it can happen with aliphatic amines, तो primary, secondary, tertiary, and aromatic primary या फिर secondary amines. Okay. It should have at least one hydrogen atom. Nitrogen के पास क्या होना चाहिए? At least it should have one hydrogen atom, the NH2. I will show you the reaction first of all. So for example, if I have two carbon atoms and nitrogen with two hydrogens like this, with a lone pair electron, it is going to react with a acylating reagent. Acylating reagent are, it can either be acyl chloride, it can be ester, or it can be anhydride. So the most easiest example is for acyl chloride. So I will take, let's take two carbon atoms, C double bond O and Cl. Okay. Now, if I look at this nitrogen atom, it is having a lone pair electron. That is why it is going to be electron rich. The carbon atom which is connected to the oxygen via double bond and chlorine, it is what? Highly delta positive. So this nitrogen atom is going to attack on this carbonyl carbon first of all. As soon as it attacks on the carbonyl carbon, the carbon will break the pi bond because it cannot have more than 5 bonds. Then you will write this as O negative. We have the Cl here, okay, and I have the nitrogen atom with two hydrogens and a positive charge because nitrogen के पास 4 bond हो जाएंगे, one carbon atom and two carbon atom. Okay, so this nitrogen has been attached to O negative. Now this chlorine atom halogen hai, so halogen obviously is a very good leaving agent. Okay, it is a good leaving group. So first of all, what happens? One of the hydrogen of nitrogen, it leaves यहाँ पे ऐसे, gives the electron to nitrogen and it is neutralized the nitrogen atom here. And simultaneously, what happens? This chlorine atom leaves and this oxygen negative, it forms the double bond here. So what are the changes? This is now double bond O. Chlorine is gone. So I can make the bond here with nitrogen here. This nitrogen is going to have a hydrogen attached. And this nitrogen is further going to have two carbon atoms like this. Can all of you see that? Yes or no? Please tell me. Can all of you see that? Yes or no? Any problem? Tell me, guys. Now this bond, it is known as amide bond. Okay, it's quite strong bond and it has biological importance also. Please write this down. Now, in this case, we have formed an amide. Okay. If you want to name this, this is my functional group, CONH2. This is what? This is amide. Unsaturation is going to be AN. Then my parent is going to be these two carbon atoms in the main chain, that is eth. Okay, so we have amide and then we have AN. And then we have eth. Now we have got the parent, unsaturation, and the functional group. Then remaining part is this is my substituent. This substituent is what? It is ethyl. Now, ethyl is attached to which carbon atom in the main chain? It is not attached to the carbon atom in the main chain. It is attached to nitrogen. So we'll name this as N-ethyl. Ethane amide. Please write this down. Right here. Aliphatic and aromatic primary and secondary amine. Reacts with acid chloride anhydride and esters. Esters to form amides. Then everyone is please tell me. Okay. So here you have acid chloride, anhydride, and esters and everything. There is a reaction that is like vaguely mentioned in NCERT about reaction of carboxylic acid with amines. ठीक है ना? तो अगर आपको याद हो, if you have R's NH2 plus some R dash COOH, then it is going to form RCOO negative and NHTR positive. So it is going to give you what? Salt. Okay, this is substituted amine salt. Please write this down. This reaction is like mentioned, not mentioned, it is just there in the NCERT just as a sentence, okay? Because we have seen this reaction of carboxylic acid and ammonia in the previous chapter of carboxylic acid. After this, write an important reaction, carbyl amine reaction, fourth one. Carbyl amine reaction. In carbyl amine reaction, we have amines, RNH2, plus chloroform, CHCl3, and KOH. In the presence of heat, they form isocyanide, RNC. Plus, there will be KCl and water. This reaction is known as carbyl amine reaction, and it is also known as isocyanide test, which is used for the test of primary amine, because this can be only given by primary amine. Please write. Aliphatic and aromatic primary amines forms isocyanide on heating with chloroform and potassium hydroxide. This thing is known as isocyanide and also known as carbyl amine. Okay, right, next. Isocyanides or carbyl amine have a very foul smell. Hence, this reaction is used for the test of 1-degree amines. Done, everyone? Yes or no? Please tell me. Done, guys? Let me know, please. You're done. Right, next. Reaction with nitrous acid. Nitrous acid is ONO. ONO. Okay. First of all, ONO is prepared in C2 by reacting NaNO2 plus HCl. Please write. HONO is prepared in C2 by the reaction of NaNO2 and HCl at low temperatures. at low temperature. At low temperature. We have different types of amines. We have primary amine, then we can have aromatic amine, we can have secondary amine, we can have tertiary amine. So all of these amines, they react differently with nitrous acid. First of all, look at primary amine. Now, if I have primary amine, that is RNH2, it reacts with ONO. And first of all, it gives you a salt that is RN2 plus with Cl negative. And on further treatment with water, it gives you alcohol, ROH plus N2 plus HCl. ठीक है, अगर आप लोगों को याद हो, I have done this reaction for the method of preparation of alcohol also. Reaction of ArNH2, it gives alcohol. Okay, so this is the reaction of primary amine. इस तरह के जो salt होते हैं ना, when you have N2 plus and Cl negative, these are known as diazonium salt. Diazonium salt. So what we can write? We can write 1 degree amine forms 1 degree alcohol on treatment with ONO. दूसरा है आपका aromatic amines. Is right next. या फिर एनिलीन लिख लीजिए, है ना, इन जनरली एरोमेटिक अमीन्स. So aromatic amine is NH2. Reaction with ONO, it is going to give you N2 plus Cl negative. This is benzene diazonium chloride. Okay, diazonium salt तो होती है. This is what? This is benzene diazonium chloride. Okay, and benzene diazonium chloride, you must have remembered this in the Sandmeyer reaction, haloalkane haloalkane. Okay, we start with benzene diazonium salt. This is benzene diazonium क्लोराइड. आपको लग रहा होगा सर Cl तो है ही नहीं यहाँ पे, Cl तो यहाँ पे है ही नहीं, कहाँ से Cl आ रहा है? So because ONO is prepared how? ONO is prepared with NaNO2 plus HCl, है ना? इसी वजह से यहाँ पे you will have chlorine always. Okay, so we have NaNO2 plus HCl which gives you nitrous acid. This is benzene diazonium chloride. Plus you can get water and NaCl also, but those are not very important. सेकेंडरी एंड टर्शियरी अमीन जो है आपके सिलेबस में वैसे तो है नहीं, बट NCERT अगर आप पढ़िएगा, दे हैव जस्ट रिटन दैट दे रिएक्ट विद नाइट्रस एसिड इन अ डिफरेंट मैनर. फिर भी आप लोग लिख लीजिए. फॉर एग्जांपल यू हैव R2NH. ठीक है, इट विल रिएक्ट विद ONO यहाँ से आपके पानी निकल जाएगा, and you are going to have R2 nitrogen. This nitrogen, it will have a double bond with this nitrogen, and this nitrogen is going to have, एक सेकंड, यहाँ पे डबल बॉन्ड नहीं होगा. This nitrogen will have single bond only because it is already bonded with two R groups. It will have nitrogen and double bond oxygen here like this. This is known as nitrosoamine. And यहाँ से पानी निकल गया, so you will have water. This is for 2-degree amines. Right, for 3-degree amines, you have R3 and nitrogen plus HONO. Now, first of all, it is going to give you nitrite salt that is going to have a formula of R3N with a hydrogen. And this nitrogen will be further bonded with NO2. Okay, so this nitrogen is going to have a positive charge. This NO2 is going to have a negative charge. So in total, this is completely neutral and it is a salt with a positive and negative charge. And when you warm it, you are going to get nitrosamine and an alcohol. That is R2 N double bond O plus ROH. Then everyone is on OPC me. How guys done? आगे बढ़े, हाँ या ना?
Done, sir.
Right, next. 6th one. A reaction with aryl sulfonyl chloride. Aryl sulfonyl chloride. Now, aryl sulfonyl chloride का जो स्ट्रक्चर होता है, that is benzene ring, sulfur with a double bond O, sulfur with another double bond O, and there is a chlorine atom here. Okay, इसका जो रिएक्शन है, it is very similar to the reaction of असाइल क्लोराइड जो हम लोगों ने देखा था. वहां पे भी आपके पास क्लोरीन निकल रहा था और नाइट्रोजन एटम अटैच होता था सल्फर से. यहाँ पे भी सेम चीज होगा. And this is also known as Hinsberg reagent. This is Hinsberg's reagent. Okay, so first of all, let us see if I have a primary amine. In this case, you have the benzene sulfonyl chloride as double bond O and Cl plus, let us suppose you have NH2 and there are 2 carbon atoms like this. ठीक है, तो यहाँ पे आप ऐसे कर लीजिए. This nitrogen atom is here and there are 2 hydrogens. ठीक है, अब ये जो हाइड्रोजन है, it is going to attach with chlorine और ये नाइट्रोजन किससे अटैच हो जाएगा? सल्फर से. So you are going to replace these two. You have sulfur double bond O, the sulfur now will be bonded with nitrogen. This nitrogen has a hydrogen and there are 2 carbon atoms like this. अगर same reaction होता, okay, if we had the same thing and we had here a primary amine rather than primary amine, if we had a secondary amine like this, if this was not hydrogen and this was CH3, तो बस क्या चेंज होता है यहाँ पे? This hydrogen will not be there, the CH3 would be here. This will be CH3. अच्छा, अब इन दोनों में फर्क क्या है प्लीज देखिए. Here we have a hydrogen atom on nitrogen, and here we don't have any hydrogen atom on nitrogen. The hydrogen in the first case, okay? The hydrogen in the first case, it is what? This is very acidic. Why it is acidic? Because if you remove this hydrogen, we will get a nitrogen में negative charge. This negative charge can be in resonance with this oxygen atom here. ठीक है ना? तो यहाँ पे ऐसे इसका resonance हो जाएगा. That's why it is what it is acidic here. If it is acidic, that means it is soluble in alkali, right? It is soluble in alkali, and this is what this is not soluble in alkali. Now, Hinsberg test can be used for the distinction between primary and secondary amine. Please write next. Hinsberg's test is used for a detection of 1 degree and 2 degree amines. ठीक है, यहाँ पे 1 degree amine plus Hinsberg reagent soluble in alkali. Two degree amine plus Hinsberg reagent not soluble in amine, sorry, not soluble in alkali. And if you have 3 degree amine plus Hinsberg reagent, there will be no reaction. Why? Because it does not have any hydrogen. ठीक है ना? एक हाइड्रोजन होना चाहिए ना HCl बनाने के लिए. That hydrogen is not present in 3 degree amine. Please write 3 degree amine does not react with Hinsberg's reagent as the nitrogen of amine does not have any hydrogen. Done everyone? Yes or no? Please tell me.
Done, sir.
Right, next. The electrophilic substitution, okay, of aniline. Now, if you look at aniline, aniline has a lone pair on key atom. This nitrogen atom has a lone pair, so it is going to give the electrons here, and what is going to happen? You will get a resonance hybrid structure with a delta negative, and delta negative at ortho and para position. So it is what? It is electron donating group. It is an activating group, and it is very activating group. Why it is very activating group? Because nitrogen has a lone pair electron, and if I compare nitrogen to oxygen, nitrogen is going to be what? Even more available for giving electrons. Why? Because nitrogen is less electronegative. If it is less electronegative, it can give electrons quite easily. So it activates the benzene ring so much, that if I have bromination, for example, in case में let's say you have bromination. In bromination, what happens? Br2 in the presence of just water, even you don't need anything else, just bromine water, and you get NH2, Br, and one more Br. So we have got tri-substituted bromine here. We have got tri-substituted bromine. Okay. Now, how to get mono-substituted bromine? Okay, mono-substituted bromine के लिए, so we have to protect the nitrogen of NH2. We have to protect the nitrogen of NH2. So for that, we add acetic anhydride. Please see here. We have NH2, and we react this with double bond O like this. यहाँ पे वही सेम रिएक्शन होगा जो एसाइल क्लोराइड के साथ हो रहा था. It is going to attack like this. ठीक है. और एक हाइड्रोजन इसके पास आ जाएगा. This will leave as the leaving group, and you will get a structure like this. Please see. The benzene ring as it is. The nitrogen atom. This nitrogen is going to have one hydrogen, and it will be bonded with the carbon atom that is containing carbonyl group, and then the CH3. ठीक है. अब देखिए. Now this lone pair of nitrogen atom, which was responsible for the resonance and activating the benzene ring, this nitrogen atom के पास दो possibility है. It can either do resonance like this, and it can also do resonance like this. So what we have done, by acetylation of this aniline, we have made the lone pair electron, which was responsible for activating the benzene ring, less available. It is not available for only benzene. It can do resonance in two different directions, and that is why the effect of resonance will be less. The effect of resonance will be what? It will be less here. So please write. First of all, NH2 group is highly activating. NH2 group is highly activating and usually gives tri-substituted product in electrophilic substitution reactions. To control this, to control this acetylation, with acetic anhydride, is done. Then the desired electrophilic substitution reaction is followed. Okay. So once we have done the acetylation, now if I add Br2 with water, bromine water, तो देखिए ऑर्थो पोजीशन में एक तो सबसे पहली बात क्या हो गया है, these ortho position, if you look at these ortho position, these are now hindered, है ना? यहाँ पे आपके पास these have very big CO then CS3 group, so these are quite hindered, and you will be getting only para products here. Get NH, C double bond O, CS3 and the Br here. अच्छा, अब उसके बाद how to get the aniline once again? So you just need to react this with, you just need to do hydrolysis here. अगर आपको याद हो, we can prepare amines from what? We can prepare amines from amide, है ना? कैसे? By hydrolysis. We'll have H plus or acidic or basic hydrolysis, OH negative. And this will give you the Br as it is. The amide will be converted to NH2. Write this down. Done everyone? Yes or no? Please tell me. Is everyone done?
Yes.
Right, next, nitration. Okay, so we know that nitration is done with concentrated HNO3 in the presence of concentrated H2SO4. Okay. Now we have plenty of H plus atom in the solution, in the container where this reaction is happening. We have plenty of H plus because it is completely acidic condition. So nitrogen atoms lone pair, what will happen? This can also attack to H plus. This can also attack to H plus atom, H plus ion here. So if it attacks on the H plus ion, it will become deactivating. Why it will become deactivating? Please see. You have N, you will get 3 hydrogens and a positive charge. Now there is no lone pair and the resonance will be like this. This pi bond is going away from the benzene ring. That is why you get different types of product. You get NH2, NO2 para position, plus you also get some meta position NO2. And a very small amount of ortho NO2. Okay, this is 51%. This is 47%, and this is 2%. So why this is happening? Please write. In the presence of concentrated acids, the NH2 of aniline gets protonated and becomes deactivating and meta-directing group. Hence, it also gives M-nitro aniline with O and P isomers. With the ortho and para isomers, that means with ortho nitroaniline and para nitroaniline, we get meta nitroaniline. So how can we stop this? We can stop with this. We can stop this with the same thing, that is acetylation. So we will have NH2, the aniline like this. ठीक है, अगेन आई एम सेइंग ये कैसे बन रहा है, CH3 C double bond O, okay, oxygen and then CH3 C double bond O. ठीक है, so CH3 C double bond O twice and then you have oxygen. This is acetic anhydride. This in the presence of pyridine. Pyridine इस वजह से यूज करते हैं because you have HCl forming, HCl को neutralize करने के लिए. So you write next. Here you will get nitrogen in the presence of C double bond O CH3, and here you will have one hydrogen. The lone pair is what? It is completely delocalized. ठीक है, it is not localized. तो ये यहाँ पे क्या होगा? It is not going to get protonated. नाइट्रोजन का लोन पेयर जो है वो अवेलेबल ही नहीं है बिल्कुल. कभी वो ऑक्सीजन के साथ रेजोनेंस में है, sometimes it is resonance with the benzene ring. Okay, so it cannot attack on the proton because it is not present on the nitrogen itself. ठीक है, वो घूम ही रहा है दो. And after that you have HNO3, H2SO4, we'll get nitrogen, hydrogen, C double bond OCH3, and the NO2 in the para position. Again, ortho position is sterically hindered, and after that you can just have H plus or OH negative in the presence of water. Aqueous condition mein, you will get the NH2 group back.